Hey, welcome back to your favorite pre-calc class. This is section 3.2, building linear models from data. We're going to take a look here. First is a scatter diagram. So in baseball, the on-base percentage for a team is the percentage of time that the players safely reach base. And the data given on the next page here will represent the number of runs scored, the output and the on-base percentage input X for the teams in the National League during 2013. So we're going to draw a scatter diagram and using a graphing utility there to graph those points. So here's your data. Notice your on-base percentage, your X there. Right, your on-base percentage, your X, your runs scored for the team being your Y, and there's the coordinates to the right of that they put in parentheses there. Okay, so I copied all those. If you go to desmos.com, 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 if you notice, if you click right here in the upper left and you click on table, it'll allow you to input this in as X1, Y1 there, and it'll do the little scatter diagram for you. Okay, and you notice that it kind of has a pattern to it. You notice as your on-base percentage or on the horizontal axis, your X's goes to the right as it increases, that the runs scored, the Y values go up. Fortunately, I can't write on this right now unless I'm in OneNote. So that's the you notice that relationship there increases as the other increases there. So what we're going to do now is talk about kind of the patterns to scatter diagrams. So we could either have some sort of a linear pattern, right, where the data follows a line, linear pattern, right? Either it's increasing like the stuff we just did, or maybe you have a decreasing linear pattern, or maybe it's nonlinear like these three. You notice this one's kind of like a quadratic, that one's more like a cubic, this one's more like an exponential, but these are all nonlinear down here. They do not follow a line pattern, right? So which one of these are linear? Are they linear or nonlinear? If you notice A, you say, well, that looks like it's following a linear pattern, a line pattern. This one definitely not. Here's nonlinear. Nonlinear again. This one's kind of exponential. Again, nonlinear on that one. So now what we're going to do is we're going to go back to our data. We're going to select 2 points on the equation, 2 quality points, kind of like the best points, if you will, that goes through that scatter diagram. If you were to draw a line of best fit through, you pick 2 that are close to being on that line, and we'll create an equation. So here's the points that are really nicely. If you go back to desmos.com, you can click on these 2 points, and you'll notice they kind of go right through the middle there. We're going to call that x1, y1. We're going to call this one x2, y2, so we can write the equation of the line. And first we find the slope. So if you remember, slope is y2 minus y1 over x2 minus x1. So we go ahead and we run that, and we end up getting the 52 there. All right, so our slope is 52. Now we're going to put it into our point slope form right here and work it out by plugging in slope, our m, our x1, and our y1, work it out, and you got your model for the data. It's a pretty good model, picking 2 quality points from the line. Now what else we can do, and here's showing using, notice it goes right through those 2 points that we picked. Right, we picked those 2 points, and it's a pretty good model of the data. But we can do a little better. We can use a graphing utility to actually find the line of best fit. This is called linear regression. It's using a statistical analysis called regression to find the line of best fit, the best one that has the least error in it, if you will. So it's the best one that gets closest, or that models those points the best. So what we're going to do is we go back to desmos.com, and after you've input your data, what you want to do is you just go down here and you enter Y, and you got the little approximation symbol, Y1, I'm sorry, because you got to use your Y1 data as approximately mx1 plus b. And what it does, if you notice, is it spits out your m, your slope. It gives you your slope, and it gives you the y-intercept, the b right there. So it's giving you the m and the b for that black line right there, which is the line of best fit using the regression model from statistics. And by the way, it's not a stats course. We're not too concerned about these other things, but R squared is your variance, R is your correlation. If your R, your correlation is close to 1, it's a pretty strong model. You notice it's 0.8959. All right, but what we're concerned with is that M is 49.3952 and the B, which is negative 906.293. So that's what gives us our model. So we got y equals mx plus b. Our m was 49.395. Our y-intercept is negative 906.293. Alright, so here's the line of best fit. Okay, thanks for listening. We'll see you guys in class.